Most RAG issues start in ingestion. Use deduplication and version tags so retrieval stays clean. If your retrieval returns noisy or duplicate passages, you waste calls and lower answer quality. In this video, you will learn how to chunk documents with stable IDs, detect duplicate chunks, and attach version tags so updates do not corrupt your index. By the end, you can build a simple ingestion pipeline that keeps retrieval tidy and manageable. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. In production, ingestion is where messy data becomes usable vectors. Teams feed raw documents into a search index and expect it to stay accurate as documents change. Success means responses are relevant, duplicates are rare, and updates replace content without orphaning old chunks. This pipeline is not about fancy models. It is about reliable bookkeeping so your retriever returns clean passages instead of repeated history or stale lines. At its core, we need three ideas. First, stable chunk IDs so the same paragraph always maps to the same identifier. Second, deduplication so we never store redundant text. Third, version tags so we know which document version each chunk came from. Imagine a few short documents split into paragraphs, where each paragraph gets an ID, a short hash, and a version label. That is the toy problem we will walk through. We will build a tiny example that illustrates each step. The code will show how to generate stable paragraph IDs, how to compute short SHA-256 signatures for quick dedupe checks, how to compare signatures against a cache, how to attach a version label to each document, and how to upsert only the deduped tag chunks into a small in-memory index. This keeps things simple and teaches the core bookkeeping patterns before you scale them. First, we prepare the documents and stable chunk identifiers. This snippet creates stable paragraph chunk IDs from tiny mock docs. This snippet shows splitting a couple of small documents into paragraph units and assigning each unit a deterministic identifier. The key idea is to combine a persistent document label and the paragraph index to form the chunk ID instead of using a runtime counter. That makes the ID stable across repeated runs when the document text itself is the same. The example also normalizes simple whitespace, so tiny formatting changes do not change the ID. Stable IDs let you compare, update, or delete specific chunks later, without guessing which record corresponds to which paragraph. Next, we compute compact signatures that let us spot duplicates quickly. This snippet computes short SHA-256 hashes to enable chunk deduplication. This snippet demonstrates taking each paragraph text and running a SHA-256 digest, then truncating the hex output to a short prefix for compactness. The short hash becomes a lightweight content fingerprint you can store or cache. If you change the truncation length, you trade off collision risk against storage and comparison speed. In practice, a short prefix is fine for small corpora and toy pipelines, but you would increase length for larger, noisy datasets to reduce accidental hash collisions. Now we check which chunks are new by comparing these signatures against a small cache. This snippet selects only unseen hashes by comparing against a small cache. This snippet illustrates loading a tiny set of previously seen hashes and then filtering the current batch to keep only hashes not already in the cache. The core logic is a set membership test, which is fast and constant time per chunk. The example shows how a small in-memory set can prevent duplicate uploads, and how you would update the cache after a successful upsert. If you expect many documents, you would persist the cache to disk or a fast key value store, but the idea remains the same. Next, we attach a version tag to every chunk without touching its ID. This snippet attaches per document version tags without changing chunk IDs. This snippet shows adding a version field that represents the document revision or ingestion timestamp, and storing that tag in the chunk metadata. Because we do not alter the chunk ID, the same paragraph in a new document version retains its identifier, while the version tag signals which revision the content came from. This separation lets you keep stable identifiers for deduplication and search, while still answering queries about recency and provenance. Finally, we upsert only the verified, deduped tagged chunks into a tiny index. This snippet upserts only deduped tagged chunks into a tiny in-memory index. This snippet walks through taking the filtered chunks and inserting or updating entries in a small index structure keyed by chunk ID, with the stored value containing the text and version tag. Because we filtered by unseen hashes, the upsert step avoids duplicate content. The example also shows updating an existing chunk when its version tag indicates a newer document, preserving stability while keeping content current. This is the minimal loop you can scale later with batched writes or an ANN index. In a real project, you would map the in-memory index to a persistent vector store and compute vectors before the upsert. The same dedupe and version logic still applies. Dedupe reduces storage and compute costs. Version tags make rollbacks and audits simple. Recap in 3 points. What it is: a simple ingestion pattern that uses stable chunk IDs, content hashes, and version tags to keep your retriever clean. When to use it: whenever you ingest evolving documents or large text batches and you want to avoid duplicate passages or stale results. One caveat: short hashes can collide at scale, so lengthen or add a checksum if your corpus grows. Next step: tune your retrieval index for scale by benchmarking with a bigger corpus and adjusting an ANN search parameter like nprobe or an index splitting parameter to balance recall and latency. If practical, example-driven AI engineering helps your projects. Subscribe and watch the AI engineering videos.